Hello, everyone. In today's video, we want to understand the use of Markov chains for company performance modeling using the SAS software. Now, before we delve into SAS, I would want to briefly talk about Markov chains and how it links to reinforcement learning. But then our objective today is that we want to simulate and analyze monthly sales performance of 13 North Dakota companies over a 10-month period using a Markov transition probability framework. So specifically, we will simulate the time series sales data, we will rank the companies monthly, and then we will compute transition probabilities of performance ranks. And then once we are done with that, we will structure the results into a transition matrix so that we can easily interpret it. So when we say Markov chains, what do we mean? We need to understand the foundations. So essentially, we are looking at a Markov transition matrix. Now, Markov transition matrix forms the mathematical foundation for reinforcement learning. So for anyone who wants to understand reinforcement learning, it is always essential for you to be able to get the foundation. So that is why we are looking at a Markov transition matrix. So when we look at our Markov chain, the dynamics of the system is represented by transition probabilities. And these transition probabilities describe the likelihood of moving from a state S to a subsequent state S prime. So in our example, we are going to be looking at the states we are talking about are the ranks. So whether the company was ranked first in terms of its sales, second, third, fourth, or fifth. Now, that is the foundation. But when you delve into reinforcement learning, then what it does is that it extends the structure by introducing two additional components. And these two additional components are the action variable that could help you to alter a state and a reward function. So that is how Markov chains are linked to our reinforcement learning. So essentially, when you look at our Markov chains, it leads us to a concept called Markov decision processes. So then the Markov decision processes will have a set of states, a set of actions, a set of state transition probabilities, and then your reward functions. So what you observed, or what you are observing here, is that the transition metrics in a Markov chain will provide the environmental dynamics that your reinforcement learning algorithms will learn to navigate and optimize an outcome. So what you must bear in mind is that the Markov chain is purely descriptive of your data. But then what the reinforcement learning does is that it is a prescriptive model. And then what it does is that it learns optimal policies that will maximize expected cumulative rewards based on the same underlying transition structure. So in essence, the Markov transition metrics we are going to learn today in SAS forms the building block of reinforcement learning, and it transforms data from a static model of state evolution into a dynamic framework for decision making under uncertainty. So with this being said, we'll delve straight into our SAS codes. So because I don't have the um, actual data, what I'm going to do is I'm going to simulate the data. So in line 18, I generate a data in SAS, and the data I'm going to generate, I'm calling it a SIAM. You can choose whatever name you want. And then what I'm doing is I set a random seed here. You can choose any random seed that you want for reproducibility. Then I generate the data for 10 months. So I have 10 months here, and I'm doing so for 13 different companies. So it means for each month, I'm going to have 13 different companies over there. And then I generate some random sales value. Now the random sales value I'm generating based on a uniform distribution, and I'm setting it between 0 and $25 million, and I'm rounding it to the nearest 0.5 so that I avoid having several decimals there. So that's what I do over here. So I'll just run this, and we'll just be sure if we are going to have our data in there. So I run it, and we come to our data environment, and I check over here, and I see a SIAM is here. So we can open it and just be sure. So this is what I'm seeing here. I see the months here, and then for each month, I'm seeing the company numbers and then the value. So this is month 1, and then I have 13 companies. Month 2, and then I have 13 companies up to the last month. So with that being said, I'm seeing only numbers for the companies. So what I try to do here is that I try to create some fictitious labels for the company. So these are a set of, or a list of companies that are around here in the Fargo Millhead metropolis. So I label company 1 to be Alerus Financial, company 2 to be Baker Boy Bakery, and so on and so forth up to company 13. So I just label the same data set and then maintain the same name. So I run it, and then when I run it, I presume I should have my company name here. So now I have company name here, and that works very well for me. Okay, so now that I have the company names, the information I need is that I want to rank each company within, I want to rank the companies within each month based on their sales value. Now, in this particular case, I'm interested in only the top 5 companies. So I say rank that data, and then when you rank it, create a new data set called ASIAM ranks, and then I want the top 5, and I want you to rank within the month and then by value. So that's what I'm doing here. So I run this here. So I should have a new data set that is called ASIAM ranks. So now I have that new data set called ASIAM ranks. So ASIAM ranks here now gives me the ranking of the companies. Okay. So now that I'm done with that portion, what I want to do here is I want to use the structured query language to compute the probabilities. So I'm computing transition probabilities, right? Now, bear in mind when we talked about the Markov transition metrics, we are trying to find out what is the probability that a company's position or rank will change in the next month. So then in essence, I need to compute the transition metrics. So when to compute the transition metrics, I call in the data set, and what I do is I join the data set to itself. So I'm calling from ASIAM ranks, and then I'm using an inner join to join the same data ASIAM rank. So I just label that as A and B, which is the same data set. So now when I do that, I'm joining based on companies and consecutive months. So that is also here. Then once I do that, the next thing I do is I try to count the number of transitions that occur from 1 month to the another. Then after that, what I do is I output my count of the transitions between the rank groups. So that's what I'm doing here. So if I run this, I should get it. Okay, so now that I've done that and I have the probabilities, the data called probabilities, what I want to do first is I want to transpose these probabilities so that I can easily read them. So you see, I have the probabilities here, but it's difficult to understand what is going on here. So then in essence, I want to transpose them using the transpose function. So I'm transposing, and then I'm transposing by the ID, and I want I want it to be from and then to, so that I'll know which of the 5 ranks are the transitions going into. Okay. So I run this. So in a sense, what I've done here is I've converted it from the long format to the wide format. Okay. So the output should give me a 5x5 transition matrix. So with the 5x5 transition matrix, I just want to make sure I'm ordering them from 0 to 4. So I'm ordering here from 0 to 4. Okay. So now that I have done the ordering, I can print my data, which is the trans table. So I have this trans table, and I just want to print this one so that we can look at it. So this is my transition matrix. So then why don't we try and understand what this transition matrix is telling us? So in the first place, the ranks we created the ranks from 0 to 4. So 0 is going to be the lowest performing company amongst that group, and then 4 is the top performing company. So what this transition matrix is telling me is that the probability that a company that was ranked as lowest will change, the probability that that company will change or will stay as the lowest in the next month is 17% or 0.17. Now, what is the probability that its performance is going to improve to the next level, which is to 1? The probability that its performance is going to improve is 0.11. Now, what is the probability that it is going to be the top? The probability that is going to be the top is 0.22. Now, let's look at a company that was ranked as the best in a particular month. What is the probability that it is going to be ranked as the 5th in that month, or as the lowest among the group. As the fifth in that month, the probability that is going to be ranked is 0.26. So this is the whole idea of the transition metrics. And bear in mind, we are seeing these type of transitions because the data was simulated, and I just simulated the data or the sales based on some uniform distribution. So essentially, we are looking at these patterns that have been created by me. But then when you get any real data, it should give you some more realistic patterns where you see some very good transitions. So this is the whole idea, or an introduction to the idea of transition probabilities in SAS. Thank you for your attention.